only. Live streaming started.
Okay.
Ma'am, are you in your mobile, ma'am?
Yes.
Then maybe you can leave and then come inside.
Okay, fine.
We'll start within another 2 minutes, right?
Yes, ma'am. Oh, resource person has joined.
Yeah. Ma'am is there already.
This person was listening to our conversations.
Who is?
Absolutely no problem whatsoever. So, no.
But we have heard a lot about you, ma'am, from our Swarna ma'am.
Yeah.
See, don't believe everything she says. Because,
Ma'am, she
you know,
says
she's a
everything
good
good.
friend.
You don't want us to believe that.
Okay. Shall we start the meeting?
Yes, ma'am.
Shreya?
Yeah.
Good evening. A warm welcome to all in this auspicious evening. On behalf of the Comprehensive Department, University of Madras, it's a moment of great privilege for me to extend a hearty welcome you all for MHRD RUSA 2.0 Biomaterials, International Congress on Industry Perspective of Data Analytics, Day 5, regarding relevance of machine learning in today's world. The great aim of education is not knowledge, but action. I'm happy to welcome Professor Dr. M. Surnam ma'am to introduce our resource person of this auspicious day, Revati Subramaniam madam, Global Managing Director, Essential Operation from San Diego, USA. Over to Surnam ma'am.
Yes, thank you, Akshaya. A very warm good evening to one and all present here. It's indeed a very happy moment, as well as I'm so excited to introduce my own classmate, Mrs. Revati Subramaniam, to this auspicious International Congress on Industry Perspectives of Data Analytics. Actually speaking, within a short notice, she has given her acceptance. So I should thank her personally, as well as on behalf of MHRD RUSA 2.0 Biomaterials Group. Thank you, Revati, for accepting within a short notice, and that too with a different time zone. And to come to the formal introduction, the first introduction I can give you and guarantee you is that she is a multifaceted personality. And we ourselves used to wonder and ask her many times, like children asking their mother, we used to ask her how you are managing your time. Because very hardly she used to sleep maybe 4 hours in a day. So we used to admire her many times that how she is managing, and that too she is dynamic and very enthusiastic, as well as whenever we see her, she is like a blossomed flower. அன்றலந்த பூ போல அவ எப்பவுமே சிரிச்சுக்கிட்டே இருப்பா எங்க ரேவதி. Really, she is a motivation for all of us, all our classmates, as well as all our friend circle. Thank you, Revati, for giving a wonderful opportunity to tell you a few things about you. And now I'll come to the religious duty of introducing the resource person, Mrs. Revati Subramaniam. She is the Global Managing Director from Accenture Operations in the Department of Data Science, San Diego, USA. And she leads a team of data scientists and engineers addressing complex problems in procurement, infrastructure, digital marketing, and more using especially artificial intelligence, machine learning. At Accenture, Revati leads a data-centric transformation of Fortune 500 companies through highly innovative solutions. Previously, she was SVP, Data Science at CA Technologies, where she successfully launched various e-commerce, 3D, secure fraud, security, and IT management analytical project suites. Prior to CA Technologies, Revati co-founded the SAS Advanced Analytic Solutions divisions and led the development of a new real-time enterprise fraud decisioning platform powered by machine learning. For her pioneering work, Revati was awarded the CEO Award of Excellence by the CEO of SAS Institute in 2011. Revati has an impressive track record of building world-class AI/ML-based product lines. She is an inventor with more than 25 patents and is a recognized data science expert with a book to her credit titled Bank Fraud Using Technology to Combat Losses. She holds an MS in Statistics from the Ohio State University and BSc in Mathematics from Mithraj College at Chennai, India. She serves as a trustee on the board of Indian Fine Arts Academy, San Diego, which is instrumental in sponsoring Indian classical music concerts by top-notch artists. She serves on the board of Athena, an advocacy organization that fast tracks women in STEM through leadership development. In addition, Revati is an accomplished vocalist in the Carnatic style of Indian classical music and trains a number of various students in and around San Diego. Revati is passionate about social causes such as human trafficking, childhood hunger, etc., and has contributed significantly towards these causes. Her other interests includes cooking, travel, community volunteering, gardening, and crafts, etc., etc., etc. So her list goes on and on and on. So I don't want to stand between the multifaceted personality, Mrs. Revati, and the august audience. Thank you, Revati, once again for giving me the opportunity to introduce you and welcoming you to this august gathering. Now the floor is open to you, Revati. Thank you.
Thank you so much, Dr. Sornam. Thank you all for being here. It is always exciting to talk to academics about industry because the interaction is always very interesting. So I appreciate the opportunity to do so. And I am a very informal person, so please feel free to stop me if you have a question. You can just type it in the chat box or you can unmute and ask the question as well. So let's keep it highly interactive. Sorna, if you can please allow me to share my screen. I would like to share a PowerPoint deck.
Yeah, sure.
Yeah, you can share.
It should be able to share. Okay. Let me try. Are you able to see?
Yeah, it is.
Yeah.
Okay, let me just make it full screen. Is this better?
Yeah.
Okay. I'm gonna try to pull this. Okay. So you're able to see it, right? And in my laptop, with all my machine learning, I have not figured this out. If I go full screen,
Excuse madam.
it just completely conks out. So I am going to,
You can go for that notepad view, ma'am.
Oh,
The full screen view on the PPT itself. Instead of a slideshow,
uh-huh.
I think it is the third icon from the left. On the right side. Like before your current slideshow, there's one icon for current slideshow, right? On the right.
Oh, this one right here. Is that the one?
You can go for the full view, yeah.
Screen. Yeah.
Okay.
Hmm.
Okay, is this better?
Yes.
Yeah.
Hopefully
Yes.
I'll be able to get out of it. So no worries. So anyways, thank you very much. And again, let us keep this highly interactive. I have a lot of material prepared with a lot of examples from multiple industries. I know for sure that we won't be able to get through all of it, but let's get through as much as possible. And some of these setup slides, I think we can go through faster. You're all able to hear me and you're able to understand my English and everything, right? No worries, no problem.
Yeah.
Yes.
right?
Yes. Yes. Yes.
Okay.
It's clear.
Okay, perfect. So again, just by way of introduction, I am the sort of the chief data scientist and global head of data-driven artificial intelligence for Accenture Operations, which is about an $8 billion dollar enterprise, within Accenture. Prior to, I've been with Accenture for 6+ years. Prior to that, very long history of building machine learning based solutions for multiple industries. I was just one of the lucky ones to catch the sort of the initiation of machine learning use for commercial applications back in the mid 1990s. There was a company called Heck Nielsen Neurocomputing Corporation, HNC Software, which arguably was the first company to take machine learning and build commercial applications that were large scale, highly impactful, on the marketplace. Because in the mid 90s, fraud was really galloping. Credit card companies had started issuing a lot of credit cards and debit cards in the US. And the government basically said that the liability rests on the banks. And so when fraud was going up, banks certainly felt the pinch and they had to do something about it. This company introduced real-time scoring, multi-entity profiling, and machine learning for the fraud problem, and pretty much cut down fraud across the globe by about 50%. Hugely successful product lines. They also did the same with respect to managing delinquencies, charge-offs, and bankruptcies, and so on. And really, the rest is history. I think they had, an amazing track record of releasing solutions. I was just one of the lucky ones to start in this company, and I did extremely well. By the time I left the company, I was executive director, product engineering, roughly 6 years later, and then went on to start the data science division for 3 different companies, I should say. So I've been a serial, what they call intrapreneur, not entrepreneur. Getting into large companies and kind of starting their data science divisions and building very useful products that address real problems in the world. So that's basically what I have done. And, I have multiple patents. I've also written a book on using technology to combat fraud losses. And so if you look at the industries that I have been lucky enough to create solutions for, certainly financial services, the government, e-commerce, security infrastructure, application monitoring, finance and accounting, retail and supply chain, semiconductor industry, as well as what we call high performance computing. So if you look at, products, offerings, really it touches, not just risk, but also marketing response, who is likely to attrite or leave, right? Who's likely to churn, as they call it. And general anomaly detection, tax underfiler detection, and lots of different applications like this. So they broadly fall into kind of three different areas, if you will. Complete unsupervised techniques, where you really don't know if you're trying to understand intrusion into a network. There you don't have prior examples of learning and applying models, right? So you have to completely rely on multidimensional outlier detection. And then you get into supervised learning, which is the other end of the spectrum, where you really have a lot of examples from the past of what has gone wrong, learn from that and extrapolate to situations not seen so far. That is the other end, supervised learning. And somewhere in between is semi-supervised learning, where you know partially what the target is that you want to predict, but not all of it. How to combine the little bit with unsupervised learning in order to come up with who should we go after and what we need to do. So in terms of technology, deep learning, of course, data mining, predictive analytics, neural networks. And neural networks, in fact, we were one of the pioneers, the first company that I worked for. So really learned a lot about how neural networks work and how to exploit them for real world problems. So that has been kind of my experience to date. I have not given you a complete laundry list of everything that I've done, but just given you a flavor for the types of things that I've done. So again, being in the media, book and patents, just gave this to you in case you're interested in checking out any of these. If you look at this website called payments.com, it was a whole series of public interviews that were done that you might find interesting. So I just thought I would leave the resources, with you in case you're interested. So what is kind of the agenda I came up with when Dr. Swarnam asked me to do this? I think maybe a week or 2 weeks ago, I really thought that I wouldn't have time to, come up with all of the material needed, perhaps. But after when I look at the deck now, I think I've probably gone a little overboard. I know for a fact that I won't be able to cover all of this, but let's see how far we get into it. The important thing is to keep this highly interactive, and so please type away. If any questions you have, please type, and I'll be very, very happy to answer any of them. So I thought I would take you through what is AI and what is machine learning, which you probably know very well. All of you, I'm sure, know. What I wanted to do was give you an industry perspective of what is AI and machine learning and what could be effective AI ML approaches. So, in industry, we do not have the luxury of doing AI and machine learning for the sake of AI and machine learning. It has to solve a real world problem effectively on time. Otherwise, the projects will get cut very, very quickly. I'm pretty sure it is true of academics too, but you have a longer runway in academics, than you do in industry, right? I mean, the patience wears out, very, very quickly. So we have to produce actual results, and also results that are repeatable, right? Not just ones that work in the lab, but results that actually work in the real world, right? That's very important. And then I want to take you through as many industry applications as is possible. There are a number of areas where we have done this. I see a typo in 3 there. It says industry. Anyway, I'll fix that. So what are the types of things that have been done in this world? Again, I am not sharing anything, confidential with you, but these are well-known approaches that have been presented over and over. Mostly the areas where I have been involved, and we have produced some very good solutions that actually solve real-world problems. So let's see here. Let me get to the next slide. So what is AI and machine learning, right? So I will be more focused on machine learning, that is the topic, but perhaps touch a little bit on AI, as well. So some of you may have seen this Venn diagram, what is data science, right? So if this is actually a quote from my book, right? So if the data doesn't support the theory, collecting more data is certainly a good idea, but most likely the theory is flawed as well. Collecting data is not possible in all realms of science, but wherever possible, data holds the key to a lot of very important secrets, in the world, if you will. So if you look at this data scientist Venn diagram that is attributed to Drew Conway, you see that there are a lot of things that are important. There is communication that is important, very good knowledge of statistical algorithms, programming, as well as very good business savvy. You need to understand, what is the business problem you're really trying to solve, right? So you see various roles here. Let's just take, one of them, right? If what you can do effectively is only communication, I would say that, that is just hot air. It's not very useful. If you kind of go down, if you're good at programming and you're good at communication, perhaps you could teach computer science. If you're very good at business, you see here, typically, you say that they're the accountant, but if you're very good at business and you understand programming, you end up as the IT person, and so on. So you see that there are so many roles that are described here, but mastering all of these is what ends up making you a data scientist, a perfect data scientist here, right in the middle. Now, if you look at data science, it is multidisciplinary. So you need domain knowledge, you need very good communication skills, because you may have built amazing models, but if you cannot communicate it effectively, it's not very useful. You have to be good at presenting the material effectively, and of course inquisitiveness plays a very significant role. Problem solving, business analysis, and business strategy, all of these, right, are needed. So if you look at the specific skills, right, so it is statistical algorithms, pattern recognition, neurocomputing, which has become a huge part of anything, machine learning, I would say. Of course, there's specific machine learning and AI as a discipline, data mining, and also databases and data processing, as well as visualizations. Visualizations to not only to understand the data, but to also be able to describe to the audience what it is that you're trying to do. Right? They say a picture is worth 1,000 words. So you need to be able to effectively show why your approach is actually going to be useful. So you very clearly see that data science itself is multidisciplinary. All of these have to come together effectively in order for us to get useful solutions, for the world, right? So if you look at AI and machine learning, very simply put,
Excuse me,
you
ma'am.
perceive the world. Yes.
In the previous slide, in the diagram, you are having so many circles which are interconnected with one another. Whether it tells any meaning, just it tells everyone is interconnected.
Yeah, well, it is also showing, for example, right, if I'll talk about the left as well as the right. Let's start with the right-hand side. So right-hand side.
Yes.
Sorry.
That is outer arrow mark, but within that we are having so many circles which are with one another, overlapping with one another. Whether it tells any meaning or just everyone depends on another.
No. There is meaning. So, for example, right, pattern recognition is part of statistics, but not all. It is completely not contained in it, because there's a lot of pattern recognition, that overlaps with machine learning and neurocomputing as well. If you take neurocomputing, right, there is a part of it that overlaps with machine learning and AI, but it's not all of it. So they actually have meaning.
Okay, ma'am.
So these are not just circles, right? On the left-hand side, if you see, it is basically showing if you have only 3 of these, right? So if you're good at communication, statistics, and programming, what you end up with, versus if you're just a good programmer and you're a good business person, what you become, right? So that is what that is showing. So if all you can do is programming, you're the hacker, right? If you can do programming and business, you're the IT guy, and so on, right? If you can do statistics, programming, and business, you basically are kind of Drew Conway's data scientist. But if you can do communication, statistics, programming, and business, then you end up as the perfect data scientist. So all these Venn diagrams they have meaning.
Okay. Thank you.
Hope I've answered your question.
Yes, ma'am. Thank you.
Okay. Sure. So what is, AI and machine learning? So you perceive the world, you analyze and understand, and you make informed decisions, right? I mean, very simply put, that is what it is, right? And AI/ML, artificial intelligence, machine learning, is a collection of technologies that enable machines to sense, comprehend, act, and learn independently or with minimal human augmentation, right? So in terms of sensing, how do you sense it? In multiple ways, through text processing, through computer vision, through audio processing, sensor processing, of course, data processing, right? I mean, I'm not mentioning data directly here so that we can expand it outside of the realm of data, right? And when you look at analyze and understand, how do you comprehend and understand? Through knowledge, natural language processing, through knowledge representation. And typically, if you look at AI, AI tends to be more, natural language processing, text processing, basically making sense out of large volumes of unstructured data. That is what is called AI today, typically, right? But if you look at the world, yes, there is a lot of unstructured data, but there's a lot of structured data that we have not made any sense of, right? And that is where, it is very important to really understand and extract value out of structured data, as well. And there are also areas where the two kind of come together, right? I mean, you have to understand some unstructured data, you have to understand also structured data and how to, put them together, right? So how do you make informed decisions? So, using machine learning, expert systems, inference engines, and so on. So all of this together, is what represents, what we broadly called AI today. So what can machine learning do specifically? Because the topic today is focused on machine learning, right? So what can it do? It can drive speed, agility, and scale. So you can capture value very quickly, change direction at pace, shape and deliver new products and services. Can be powered by diverse data, enormous and diverse data sets. Enormous and diverse data sets to create richer and sharper business outcomes for clients, right? And then you can deliver real business outcomes. So you can help become more flexible and responsive by delivering superior business outcomes. And I think fraud detection is a great example, right? So instead of looking at reports at the end of the day and then simply understanding or recognizing, I should say, which ones turned out to be problematic or which ones, actually were fraudulent transactions, we can turn that completely on its head. And as the transactions are happening, capture all of the information, have the contextual understanding of whether this particular transaction is likely to have come from, say, Revati, right? Is Revati likely to do a transaction like this? And then assess the probability that it is not Revati who did this transaction. Assess the probability of fraud happening. And then immediately say, hey, I am not even going to allow this transaction to go forward because there is a 95% probability that it is fraudulent. So you can deliver real business outcomes. So before the transaction is executed and fraud, basically the banks are stuck with fraud, you can stop it, right? You can intervene and stop the transaction. For example, right? I think fraud is a very good example that all of us, can relate to. And then drive intelligence and insights. So boost the volume of quality data by 40 to 60% to gain valuable business insights and make strategic, business decisions. That is something, we can do. And then significantly improve people's lives. So drive innovation with changing roles that drive creative thinking, working with machines, and problem solving with an entrepreneurial, mindset. Now, when we talk about improving people's lives, look at how decision making happens, today, compared to what we did maybe 20, 30 years ago, right? There is real-time feedback. We actually expect real-time feedback, right? I mean, for example, you go on a website and you search for something. Next time you get an advertisement, it is very relevant specifically to you. It's not some generic, advertisement that you have to look at. Certainly, you may or may not click on it, but decisions are modified and catered to your specific need and what your interests are. And that is certainly a direct consequence of machine learning and AI, right? I mean, we experience AI and machine learning all around us, maybe not actively, but if you start really looking at it, it plays a role pretty significantly, everywhere, around us. So let's talk specifically about artificial intelligence, domains. So you kind of see, three ovals there. The biggest one is basically any technique that enables computers to mimic human intelligence using logic, rules, decision making, and inference, including machine learning and deep learning. Okay? And then if you get to the smaller one, machine learning, it is a subset of artificial intelligence that includes statistical techniques that enable machines to improve a task with experience. The category includes, deep learning. If you look at deep learning, this is the subset of machine learning composed of algorithms that permit software to train itself to perform tasks like speech and image recognition by exposing multi-layered neural networks to vast amounts of data. And if you really look at neural networks were designed in the sort of the late 60s, I would say, to model the functioning of the brain. And they really kind of gloriously failed at that, right? The technique did not really do a good job of modeling the functioning of the brain. But neural networks are capable of identifying a phenomena with a non-zero probability. So they can identify correlations, between variables, with a non-zero probability. What I mean by that is, prior to neural networks, most of the techniques used essentially expected you to put it into the model and force, certain variables to be available, part of the equation or not. Right? So if you think that one particular variable in a model is very weak, you had the choice to drop it and so on. Whereas if you look at neural networks, because of the hidden layer, in between, you can add variables to the model. And if there is one particular interaction of the variable with another variable that is totally meaningless and not adding to the variability in the underlying data, it can automatically weigh that down. And so, you can really think of it as a little bit of magic, really, right? And, if human beings had all the time to sit and figure out all these correlations, maybe we can do as well or slightly better than neural networks. But neural networks have given us a way of taking the underlying information, understanding it, in a way that it doesn't have a lot of extraneous useless data, so that you can get very precise predictions. It gives you a way of including that kind of automagically, if you will. And that is really the tremendous role that neural networks have played with respect to artificial intelligence. And the reason I specifically mention deep learning as well as in the context of deep learning, is that it is basically the subset of machine learning composed of algorithms that permit the software to train itself to perform tasks like, speech and image recognition. I would say that the origins of it really started with neural networks, and this is a much better methodology related to that. I have a request. Can Mrs. Pechiammal please mute? Yeah, thank you very much. So these are basically the artificial intelligence domains. So with respect to selecting machine learning algorithms, so here, again, I talked already about, supervised, unsupervised, and there is also the reinforcement, right? So you predict something, you look at what the actual results are and use that to reinforce whether what you have done is correct or not correct, whether you should go and modify it, right? And the candidate models, deep neural network, SVM, decision tree, etc., and or an ensemble of models. Let me go ahead and build this. Okay, so you select a learning paradigm and a prediction type. You analyze the machine learning requirements. You select models, and optimization algorithms. Then you determine if the pre-trained models can actually be used. Right? I mean, you can build a model in the lab setting. It may do very well on your existing data, but how well is this going to extrapolate to the real world? Is something that you have to really understand before you unleash it on the real world, right? So suppose I build a fraud model. It actually does very well in the lab, but then it utterly fails in the real-time application of it. The consequences are huge. It can basically make companies go bankrupt if we don't do it correctly. So how do you extrapolate, understand, how do you test it? So that is what has evolved a lot, right? I mean, models have been, built for a long time, but in terms of getting the feedback loop, getting the self-learning in, I think tremendous strides, have been made, I would say, in the last few decades. And I've been very lucky to be, part of these strides. So let's go to the next one. So in terms of selecting machine learning algorithms, right, the model's prediction requirements will dictate the type of learning paradigm, whether it is supervised or unsupervised. Yes, please.
Madam, how SVM works?
How SVM works with respect to real world problems?
What is that SVM?
Well, SVM is support vector machine.
Yes.
So again, it's a multi-dimensional, technique where what you try to do is you try to separate out the target. Let me call it, whatever you're trying to predict, and whatever is not a problem, right? Problem versus non-problem, right? So if you take fraud, you're trying to detect fraud. If you take risk, you're trying to predict who's going to go bankrupt. If you take attrition, you're trying to predict who is not going to, stay and go away, right? Can Mrs. Pechiammal please? Yeah, thank you very much. So that is the other one. Now, if you look at support vector machines, what it basically does is it tries to create a space.
There is one terminology to use the vector. How it is related to the vector, Madam, SVM?
Oh, the way it relates to the vector, what is being talked about as the vector here is really, you can think of it as the vector that's being represented by all the variables that enter the model, right? And what kind of support does it have with respect to the problem you're trying to identify and the problem, basically the non-problematic ones, right? What kind of support exists? How do you train that, and then you figure out how to basically deploy it. And I have to say here that support vector machines, while they are very good in the lab, it's a little bit of a nightmare to actually deploy and make it function. So these are still being tried only as experimental cases in real industry applications. I would say deep learning, machine learning are much more common. I shouldn't say machine learning, really. Deep learning, neural networks, and so on are much more common for real world problems than support vector machines. But support vector machines can guide us with respect to what sort of variables would actually be useful in a particular model. We can take it offline, Dr. Pankaj Kumar, and talk about it in more detail. Okay. Okay, so with respect to selecting machine learning algorithms, again, we need to have a good understanding of the underlying problem, whether it is supervised, unsupervised, and what is it that we're really trying to do. And then if you look at analyze the machine learning requirements, it is certainly accuracy, right? Accuracy has to be high, otherwise the whole exercise is kind of futile. How long does it take to train? You may get amazing accuracy, but let's say every model takes forever to train. It takes like several months to train one model. It's not going to be, really acceptable, because we don't have the rest of we don't have a long time to implement, a lot of these things. And then linearity, right? If the data trend can be separated by straight lines, introducing linearity to the algorithms can really reduce the complexity of the problem pretty dramatically. But the problem is that most real world problems are not linear. That is why, you need these more advanced techniques. And then the number of parameters, right? There are some parameters that really affect and some parameters they may not. How do you keep the wheat and weed out the chaff, right? I mean, that becomes really, really important. And of course, you probably know all of this. I just wanted to give a broad list of, all sorts of algorithms that get used, right? Of course, in clustering, classification, regression, ensembles, neural network and deep learning, reinforcement learning, dimensionality reduction, pattern search, and so on. So you see that in terms of the data and how you can extract information out of it, that explodes, right? I mean, the moment you have millions of data points and let's say, dozens or hundreds of features, I shouldn't say features, of actual variables, that you can collect, the combinations really explode, right? Now, the number of techniques you can use, you can see very clearly, also explodes, right? So, for example, if you simply take a multi-layer perceptron, neural network, that in itself you can do in so many different ways. You can do autoregressive neural networks, for unsupervised models. So what I'm trying to say is the complexity of the data scientist job becomes pretty enormous, right? Enormous complexity, and you have limited time, and you have to produce something that's actually valuable and can save dollars, right? Save money. Because if it doesn't save money, especially companies lose interest, pretty quickly, right? So, all of these, first of all, you have to understand the theory, how to apply it practically, understand the nuances in the data itself, because not understanding what varies with what, and even the time at which things are being collected, can lead to target leak and stuff like that, right? So you cannot, I'll give you an example. In credit risk, what happens typically with respect to credit cards is that if you look risky, they're going to go ahead and reduce your credit line, because, let's say you haven't made a couple of payments, so they reduce your credit line. If you use the reduced credit line as one of the inputs into your model, what is going to happen is it is going to cause the credit line to go down even further, right? So you are essentially, that is, I would think of it as, you don't want to use that outcome in your next model, because it becomes a self-fulfilling prophecy. So somebody looked risky, you reduce your credit line, you use the reduced credit line, and so you think they're more risky, so you reduce the credit line further. We can get into this kind of vicious cycle, which you don't want to get into. So for understanding that, you need to really make the connection that, hey, the apparent risk in this particular customer is what caused the credit line to decrease, right? And so make sure that you're not making use of that information again to get into this kind of recursive spiral, right? So that requires a very keen understanding of the business itself and how things happen. So you can see how many things have to come together in order for us to build anything that is effective, right? So that's why an effective data scientist job becomes quite complex, right? So what could be an effective, approach. So, as we talked about, right, we have supervised model, we have unsupervised, we have accumulation of features, that show a mix of historical decision attributes and new patterns detected by machine intelligence. So, if you look at solution features, these are all the features that have to exist. It has to be highly parallelized, it should be linearly scalable architecture. So, you cannot completely bring the entire house down because your business grew, for example, right? You need to be able to handle the scale very, very effectively. You want to understand the multiple entities involved in any particular transaction. You need to be able to make decisions real time, near real time, on demand. So why is this important? Back to the fraud example I gave you. If you do an amazing job of detecting fraud, but you only do it at the end of the day, by the time the game is over, right? The fraudster took over the card and they've already charged it to multiple thousands. If you tell me at the end of the day that, oh, you know what, fraud happened, it's like looking in the rearview mirror. It's not very useful. So for business decisions, they need to happen then and there, so that you're able to intervene and stop the transaction, right? So rapid execution becomes very important. What I mean by rapid execution is not only how the models get executed in production, but I also mean execution of the project, right? We cannot have multi-year projects in industry where, okay, I'm going to take 3 years to build this model, because by the time you finish building it, the business may have moved on enough that it is not very effective anymore. So, but if you build it in 1 week, your techniques are not likely to be very sophisticated and give the level of precision you need. So you really need to balance, those two sides of it, right? It needs to be configurable and scalable, and also it needs to have multiple applications, right, across a number of solutions. So if you look at, AI ML augmenting humans, so, you comprehend structured and unstructured data for reconciliations or whatever that is that you're trying to do, and, use the core capabilities to essentially do whatever it is that you're trying to do, whether it is help desk emails, whether it is, you're really trying to look at claims and adjudicate them. So anything, right? You need to be able to do that, very, very quickly. And so some of the areas in which we do this today, right? In finance and accounting, in procurement, in journey to cloud, and customer service, cross-offering, we have a whole bunch of applications where we are really making solutions proactive, right? So looking at what is happening today and really trying to predict and extrapolate what is likely to happen. So what I'm going to do is spend a lot of time on fraud detection specifically, and then perhaps just touch upon a whole bunch of other areas, and then also open up for some questions. So I wanted to ask Swarnam a question. Swarnam, so this is, suppose we have another 45 minutes, or do we have more? Can you tell me how much time we have?
Yeah, exactly 40 minutes.
40 minutes. Okay.
Yeah.
Okay, perfect. So let's just, I'll take this fraud detection in more detail, and the rest of them we may not have time to cover, which is totally fine. And I also want to leave some time for, questions and some, making it interactive. So even before I get into this, right, can a couple of you either type in the chat box or ask me, what is it that you would like to see, right, with respect to machine learning having a sort of a practical impact on our daily life? Do you want to see examples, or already you're convinced that that's the case, and do you have any kind of specific questions related to how we do that? So I would love to hear from you. I'm just going to allow maybe 3 minutes here. If you have any questions, I think that will guide in what detail I want to go through the next one. Anybody? Okay, I don't see any questions. I'll give you 1 more minute. Let me go grab a cup of water and I'll be right back and see if there are any questions. Okay, I take it there are no questions. Oh, okay. What are job roles involved in this fraud detection related to IT company? And there was another question. Let's see here from Ms. U. Vagiswari. Need your inputs regarding text data analytics. Okay, I'll try to answer both of those questions. So let me take up the text data analytics piece of it, first, and I think I can show you some examples through the answering those questions as well, right? So let us imagine a very vast high performance computing cluster. Let's say thousands of engineers are submitting jobs. And what happens typically here is that engineers always request way more than what they need because they want to make sure their jobs run absolutely without fail, right? This is a real world application that we have worked on, right? And so let's say that a job really requires, 10 gig of memory and 4 cores to run the job, right? The engineer is requesting 50 gig and 10 cores, let's say, right? What happens is for the duration of the job, let's say the job runs for a couple of days, right? For the duration of the job, those resources are being held. They cannot be allocated to any other job. If you look at the actual resources the job ended up using, it's way below what was requested. And so that capacity, the excess capacity, is a total waste, right? So if there is a way that we can magically predict what would be required, for a job to run, it could be extremely, extremely useful, right? Now, when you, again, we actually have a solution that does this, right? Now, there has to be the feedback loop, right? So we have to look at job finish records because it's not all about understanding how the engineer typically requests and what kind of project the engineer is working on, what is the function he or she is fulfilling, and how do these come together. In other words, let me pick on Sorna, right? Sorna, as an engineer, while she's doing quality assessment, she always tends to request way more resources than needed. Let's say we have observed this pattern, right? And we have actually analyzed and understood it and said that, hey, as soon as she submits the job, I know that I can take the resources she has requested down pretty significantly, right? But let's say the system where she's actually submitting it has a lot of traffic today. So without requesting the level at which she did, the job may not even run. Let's say, I'm just making up an example, right? That information you'll have to gather from the job finish records, where you have to understand the text that is involved, right? So the text data analysis and the actual data that, things like how much, what are they requesting, and, who is the engineer submitting this, and what kind of function they're working on, and how do those functions typically, request for resources and things like that, right? So that is kind of numbers data, if you will, and this is text data. Both of these have to come together in order for us to effectively assess, what to do, or, what prediction should be given, for example, right? That's example number one. Example number two, let's say you're analyzing some merchant data. It's very important to understand what was the transaction that was executed, not in terms of the time, the amount, and where they did it from, blah, 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 much more than that. You have to understand kind of free form text and extract information out of it. So pretty much Anything I refer to as machine learning referring to data also includes text, but not necessarily large scale unstructured data. So text analytics, you can pretty much assume that it is it is part of data analytics, when we talk about it, and playing a bigger and bigger and bigger role, because if you don't analyze the text data, whatever you come up with becomes kind of useless, right? Because you need to understand the context of it. And there are a lot of techniques for it, right? You can create a bag of tokens, you can do factorization techniques, factorization machines, a lot of different techniques, and they have to kind of coexist with the main algorithm, whatever it is that you're using. So that is kind of a short answer, to that question. Now, with respect to what are the job roles involved in this fraud detection related to an IT company, well, typically fraud happens in a wide variety of domains. But if you look at the job roles, it's typically the fraud analyst. It is the person running the fraud shop, the manager, I would say. It is also you can think of it as any business person, who's involved in making decisions that also includes assessing fraud and so on. I mean, for example, the chief risk officer, the person in charge of fraud strategy, a person designing the next program has to have a good understanding of what is the propensity, for fraud and so on. So I would say that anything that involves risk and also the actual day-to-day operations, those are all the jobs involved with respect to this fraud detection related to IT company. So the next question is text analytics. Does it include natural language processing? Typically, the classification I have seen is that natural language processing techniques can be much more sophisticated when you're talking about large-scale unstructured data. Text data analytics is almost considered to be an extension of data analytics. And the reason for that is just simple text analysis is kind of a limited size problem. So, it is not where you're trying to understand a blob of text, a blob of data in terms of, actually written out documents and trying to make sense of it. Text data typically is related to the specific problem, and you're trying to map it to risk and include it, in the model itself. So typically text analytics is considered to be an extension of data analytics. Whereas pure natural language processing becomes much more sophisticated.
Madam, your PPT is not changing.
No, I haven't changed it. That's why. I haven't moved it. That's why. Okay. Now, having answered a few questions, let me take you through a fraud example, right? So if you look at all the different areas, if you will, that actually affect fraud, consumer behavior itself is changing, right? What are the transactions that were considered to be extremely risky, say 10, 20 years ago? People do it now without even thinking, right? I mean, I'm sure when they allowed credit cards to be used online, there was a lot more hesitation with respect to using your cards online. When all this started, but now we just use it left and right because we don't have any liability, and we know how this works. The worst case scenario is you get defrauded and you may have to to give that card back and basically get a new card, which is really minor annoyance that most consumers are willing to live with. Right. So if you look at data breaches, right, lot of data breaches happening. If you look at payment becoming digitized, right, everything is becoming digitized. There's no question of having to walk into a branch to transact. Of course, in India it is still largely that, but I'm just talking, if you look across the globe, there's online applications, there's a lot of real-time remote banking, there's a lot of changes there. Access to technology is also very different. I mean, with all the social media and the networking that happens through that. And there's a lot of social engineering that happens as well. And so that also plays, a role in fraud and how it has evolved. A lot of the organized crime have always been part of, fraud, but they've become much more sophisticated, right? And with respect to the customer experience, there's a very low tolerance of friction now. See, I remember way back when fraud systems were introduced, even me, right, when I came to the US, like in the late 80s, which is when credit cards start really proliferating. I had a few credit cards to my name, and when I used to get a call saying, hey, did you make this charge, I used to feel really good. I felt protected, even if the call was about a false positive, where it was not actually fraud. I made the transaction, and they called and simply verified, hey, there is a transaction for $1,000, did you make it? I felt very good when they called me. But fast forward 5 or 10 years, I get annoyed if I get a false positive call. I think, hey, you should know that I didn't make this transaction, right? So the consumer expectation, has really gone up, right? So all of this together, has led to a rapid, kind of evolution. It has become a global problem. It is increasingly sophisticated, and there is a large shift to digital and scams. There's, of course, pretty significant regulatory attention to it and reputational risk. So whatever systems you're building have to react to all of this. And the reason I'm mentioning, all of these sort of so-called problems, if you will, right, related to this area, it is to show you that fraud detection itself, even though honestly it has been around 25 years now. So the first large-scale use of machine learning for a problem, I would say, arguably is certainly fraud, right? I mean, true machine learning. I'm not talking about just using simple linear regression models and so on, right? So if you look at that area, even though it has been around for 25 years, it is still evolving. And so the relevance of machine intelligence to this world is really huge. So you cannot rest on your laurels. And I just want to draw a kind of a comparison, right? So let's say there is a simple procedure that gets done. Let's say that you want to get cataract surgery done, let's say, right? If you look at cataract surgeries, by the way, I am no expert and I'm not a doctor or anything like that, right? Basically based on what I've read, cataract surgeries, yes, they have evolved in terms of the length of time that people have to be in the hospital, in terms of the methodology of what needs to happen, in order to do this as quickly and as fast as we can. But the problem of cataract itself hasn't changed, right? I mean, cataract, the problem as it existed, that is how it existed 20 years ago. That's how it is now. Let's say you want to extract somebody's tooth, maybe there's a root canal, maybe there's a little bit of a problem and you want to remove the tooth. That problem hasn't evolved, right? The method to do it may have gotten faster, cheaper, or maybe more expensive. The period of recovery is very fast and all that. But with respect to all real world problems where we are using machine learning, the real challenge is that the problem itself is evolving, right? And the methods also are evolving. So to reconcile the two becomes quite a bit of a challenge. So you can never rest on your laurels, right? I mean, if you rest, you rust. You have to keep on moving, yes.
What is this dark web?
Yes. What is the question?
Dark web.
Yes. And what do you want to know about dark
data
web?
breaches?
Yes.
Second.
I'm only able to hear every other word. Dr. Pankaj Kumar, can you please repeat the entire question or maybe type it?
Dark web. DARKWEB. Web.
I understand dark web. What is your question?
What is that dark web?
Oh, the dark web is the basically a part of the internet where if there are data breaches and they find large scale credit card numbers or account numbers or usernames and passwords, these are basically being sold to other fraudsters, who want to take it over for a short period of time and gain, financially, right? That is dark web. But the security for the dark web is so tight that it is not possible for you to get into the dark web, figure out that, hey, these are the things that are being sold and stop it. Right? So, the idea of actually figuring out what is being sold and figuring out a way to stop it is not easy in the dark web. It's not something that can be done very easily. Okay, so if you look at, hold on just a minute, let me try to get to the next slide. So now fraud involves many players, parties, and components, and it is an ever-changing and evolving problem, right? So if you look at the food service and hospitality industry, the median loss is about $114,000, right? Now, 55% of all credit card fraud in the US takes place in the hospitality industry. And if you look at transactional fraud, there are so many different types of fraud. Now, the reason I'm mentioning all of this is that the underlying algorithm has to keep on evolving and changing. It has to keep up to speed with respect to the problem itself that is evolving pretty significantly. And so there are new techniques of how transactions happen, right? So when they introduce a new payment channel, you have to figure out how you're going to stop the problem there, right? So the underlying problem is changing, and the technologies are also changing. The ways in which we are interfacing are also changing. And so it makes for a very complex problem. So for example, as a comparison for that from the medical world would be like the various different types of cancer that perhaps did not exist 20 years ago, or we didn't understand that they existed, and how we tackle all of those, can be a good extrapolation or example. So it makes it extremely, extremely difficult. And this is why it is important for the techniques also to keep evolving. Right? I mean, we cannot just rest on, oh yeah, we have done a very good job of it, that's it. There's no resting. It's not like, okay, I've solved this problem, that's it, I don't need to worry about it. Absolutely not the case. Even if you have solved the problem very well, you have to keep on being very proactive and keep, evolving your methods, right? So if you look at, application of AML solutions, right, in fraud detection, is online fraud detection, payments and plastic card fraud detection, e-commerce authentication fraud, is an area that has actually evolved quite a bit as well. It used to be all based on software authentication. What I mean by that is giving a password or a password and a one-time passcode, stuff like that, right? From that, we have evolved to something that basically happens where an algorithm is assessing whether there is even a likelihood of fraud in this case using information on the device. So is this particular transaction actually originating in XYZ country that is prone to have a lot of fraudulent transactions? Also, there is no reason for Revati to do a transaction from Bulgaria right now, because we haven't seen her, travel there through the credit card transactions. All of a sudden, there is an online transaction coming from Bulgaria, let's say. It just doesn't fit with Revati's profile, because even though she travels a lot, I've never seen her go to Bulgaria. And just yesterday, I saw a transaction from Columbus, Indiana. There's no way she could have gotten to Bulgaria within this period. And so using information like that to actually stop the fraud in authentication, as opposed to expecting you to remember a password, where most consumers do not remember the password, whereas fraudsters figure out a way to get around it, right? So that's one area where machine learning has completely turned the problem on its head. Instead of authenticating 100% of the transactions and essentially losing about 10% of the transactions, to solve a problem that's perhaps 0.05%, what you've been able to do is only having to assess more deeply 2 to 3% of the transactions and capturing most of the fraud in there. Huge strides have been made. Cybersecurity and resiliency, analytics. So with respect to cybersecurity, understanding intrusions. In fact, understanding intrusions, you have to assemble lots of different pieces of data in order to get it, because a lot of these intrusions are slow and low. They just get into the system slowly and grab one packet of data at a time. How to understand that pattern, assemble it, and say, hey, something serious going on, and stop it. If you look at application internal fraud, customer authentication, analytics, bust out fraud and detection. Bust out is where they make an application, they gain control of some financial instrument. It could be whatever, right? I mean, typically a credit or debit card based on fake identity. If you look at credit card, they just charge it to the hilt month number 1, and then they never make a payment. That is a bust out. So you need to understand it 2 or 3 transactions into it. If you wait a month and say, okay, I'm going to establish a pattern and then decide, game over. It's too late already, right? Similarly, application fraud detection, you don't have a whole lot of data, how to basically do that. I see bust out repeated here. Need to fix that. Then e-commerce in-store pickup fraud, right? Online order fraud, friends and family in-store pickup. So what we mean by that is, you basically order and you say that, you're going to pick it up in store, and they keep it ready, but the transaction is not being made by the actual cardholder, but by somebody else. And then collusive fraud. Again, here, certainly dark web plays a role. So what I have seen is there are layers of fraudsters. So they basically grab, credit card numbers, through data breaches and stuff. And the fraudsters say that, hey, I've only made 1 transaction on this card. And then, I'm going to go ahead and sell it to the next person in line. And they make 1 more transaction, they sell it. So progressively, the value of the card reduces and what value it gets sold for reduces. So there's a whole industry around, collusive fraud. Again, you need to be able to understand the patterns and react to it, extremely quickly. Network detection, analytics, if there is some sort of a large fraud network that is operating, how to identify and stop it. In terms of returns fraud, you can claim that you never received an item. This is something a lot of e-commerce companies face, because they are not going to get a signature and deliver, because the cost of delivery becomes too much. So they just leave it on your front porch. You call and say, hey, I never received it. And so the e-commerce companies, typically, at least in the US, they don't want to really bother the consumer. They immediately credit you back, with the amount. But you need to have a handle on the overall problem, right? If 10% of all your sales end up as non-receipt fraud, that's a serious problem, because it can really take your business under. How do we manage it? How do we actually make sure that this is not hugely detrimental to your business, right? Becomes very important. And SKU management to effectively, manage fraud. So here again, you're really managing certain categories of things that you sell much more tightly and effectively than others. Those could be like the more expensive ones, or the ones that are more likely to be defrauded, right? You look at that. And then first party fraud is where I open up an account with a specific intention of defrauding. I have no intentions of paying my bill, right? So, and the difference between first party and bust out is that bust out is the first time application as well. But first party fraud could be where I've had a credit card with me for a long time. There is an item I decide to purchase that I've never purchased before. And then I claim that I didn't make that charge, so that the bank, actually gets stuck with paying for it. So again, you can see all of these areas, very effective AI/ML solutions have been implemented and successfully had impact on all these different types of fraud, where we've been able to bring down the fraud losses by a huge percentage, right? So for the first time, when fraud detection was introduced for credit card fraud across the globe, fraud losses used to be about 16 basis points, so 0.16%. And we were able to bring it down to like 7-8 basis points, about half of what it was. So it had a humongous impact. Again, talking about real world applications, I think, fraud is a really awesome example of where machine learning has played an amazing role. Right, so let's see here. I'm going to skip through, some of this and just take you through just a few examples of what all can be done in finance and accounting, for instance. So if you look at finance and accounting, let me just, kind of set the stage for what are the types of things that actually happen, right? So typically what happens is that, you onboard the customer, and then essentially what this is it's business to business transactions. So let's say I'm a large technology company and I'm selling to my constituent consumers, which may be small businesses. And what I do is there is an order that comes in, the order gets entered, the order gets validated, and then there is a customer interaction with respect to any disputes or any returns. And then there is pre-billing, and then there is actual billing and invoicing going on. And then there is customer interaction and disputes management. Then there is the cash collection process, cash application, account reconciliation, and then you manage bad debt, right? Now, at every stage of this, what used to happen, let me just go back to the, previous one. So what happens here is that typically, let's just take the collection piece of it, for example. So they would send out a bill, basically an invoice, right? And let's say I send it out on January 10th, and the invoice is due on February 10th. And these are business to business transactions. And so these are not business to consumer. So the reason I say that is, if they're business to consumer, if you know for a fact that Revati has done multiple times, she makes a charge and then say denies that she made a charge, you have a recourse. You can reduce my credit line, or you can say, sorry, next credit card you apply to, we're not going to give it to you, and so on. But in business to business transactions, you really don't have that recourse. You don't have the luxury of telling your customer, sorry, I'm not going to do business with you, right? That option doesn't exist. So when you send the invoice and they're supposed to pay a month after, typically what happens is that till the end of that month, so let's say you send the invoice out on January 10th, it's due on February 10th, they haven't paid, you wait till the end of February, right? Because you don't really want to upset your customer. And then you start calling them to say, hey, what happened? And typically what happens is that these customers will start raising some issues about the bill. They'll say, oh, this doesn't make sense, that doesn't make sense. So they go back and forth, and this goes on for another month. If you look at it from the technology company's perspective, essentially, they have been out of money for 3 months, and it becomes a cash flow problem. So I've sent my stuff out, I've invoiced you, you haven't paid me, and we are still in this clarification process. So the cost of capital becomes, pretty significant. And what we were able to do was turn this completely on its head. In fact, the solution won the Adam Smith Award by Treasury Today magazine. Again, nothing I'm sharing with you is really confidential. What we were able to do was, as soon as the invoice gets sent out, we were able to predict very accurately which invoices are going to not get paid on time. Now, when I talk about accuracy, I'm talking 95% plus accuracy, because unless you get that sort of accuracy, you cannot really act on it. So you need to be able to identify a set of invoices where there is a very high likelihood that they will not pay on time. And what you do is you use the period in between invoice production and the actual date due to clarify, any issues that might come into play. So you call them and make sure that, hey, everything is okay about the invoice, right? I mean, there are no issues, right? And so on. So you clarify it so that come due date or the end of due month, they cannot come up with reasons why, they're not able to pay you, right? And also, even when the order comes, if you can predict very accurately which ones are going to end up with some sort of disputes, you can very effectively try to stop it as well, right? So these are areas in finance and accounting where typically prediction is not made use of, right? So what was happening was only looking in the rearview mirror, right? After the fact, you just look back and say, oops, they didn't pay on time. But we were able to turn that completely on its head and change it into, hey, I'm actually going to predict as soon as the invoice gets generated based on past patterns of what I know about this consumer, about this geography, about the type of transaction, the goods they are purchasing. I can actually predict that there's going to be a problem and give that list to your collecting agents so that they start calling even before the bill is actually due. And this was a revolutionary idea in the area of finance and accounting that has improved cash flow for some of the largest companies in the world by very significant numbers, right? So this award was, basically received, partnering with a very large, perhaps one of the largest technology companies in the world. And the kind of impact we were able to have was just amazing. Just want to give you kind of one example. Again, I'm going to pause here. I think we have about 10 minutes or so, or maybe even a little less, based on what Sorna
Yes.
gave me. I'm
Yeah,
going to pause and see if there are questions, please. Yeah. Any questions, comments? No? Yes, please go ahead, Sorna.
Yeah. So the speaker has fantastically given her input. Due to the time constraints, she couldn't complete that full length of her session. But anyway, I think she'll be sharing the PPT and we will circulate with the participants. And few are saying that a very interesting session. And of course, some of them, they have raised their research-oriented problems even, and they got it clarified. And to be frank, I should owe a lot to Mrs. Revati Subramaniam for giving a wonderful session at this time. And when she was talking, I'm just recalling that, oh, such an early time she is waking up and giving this lecture. So it is really a boon for us. Even though we are geographically apart, it is a boon that we are connected with internet connectivity. Thanks a lot. Thanks a lot for this digital era where we are living. And you have given so many real-time examples and the industry perspectives also. You have made an eye-opening to the audience. I hope that this will be a real brainstorming session for the beginner, those who want to indulge themselves into machine learning or AI or whatever the area they want to fix. So we have just thrown a light onto that. So thanks a lot, Revati, for your wonderful session. And please join us for the valedictory function that is going to start within few minutes now. Thank you so much.
Okay. Thank you so much. Thank you. Thank you.
Thank you, ma'am. Thank you for sharing your pleasant words towards us. It gives me an immense pleasure to deliver vote of thanks for this event to all dignitaries assembled here. I would like to thank our resource persons of this day, Revati Subramaniam ma'am, who honored this function with her inspirational thoughts. And thank you, ma'am, for joining with us. Thank you all.
Thanks a lot. Thank you so much. So Swarna, I can leave the meeting now?
Yeah. Very well. You can
Thank
leave the meeting. But
Thank you.
our kind request is you can join for the valedictory function.
So is
If
it the
possible,
same
if
Zoom
possible.
link? Same Zoom link?
Same Zoom link.
So it is in 5 minutes or so?
Yeah, exactly.
Okay, I'll try it. Thank you.
Yeah. Thank you so much.
MS ma'am.
Yes.
Her time is 2:30, I suppose, 2:30 or 2:45 a.m. So
Amma.
don't compel her to join later.
இல்ல அவங்க now she has moved to Indiana, Columbus. There the time is 4:20, she said, when we started.
Oh, then okay.
Not in San Diego, she is now.
Okay, ma'am.
So she has just traveled a little far. So that is why the time difference. So she could able to, yeah.
Okay.
Yeah. Should we tell Bhaskar sir or?
Yeah, sir can join.
Yeah. He has joined?
No, not it.
Not it. Okay. If possible, Lavanya, can you just call him?
Yes, ma'am.
Okay.
So dear participants, feedback link will be shared at the end of the validity function. During the validity function, we request some participants to say a few words about the feedback of the International Congress. Please get ready. Please hold on for some more minutes. Our guest will join with us.
Yeah, he's joining now.
Thank you.
Dear participants, I hope you all had a very good knowledge sharing sessions with all eminent resource persons. So hope you will take home the knowledge shared and use it for your research and academic purposes.
Definitely, ma'am.
Yeah. So, and you can also take this opportunity to share your thoughts and comments during our validity session, during the participants feedback session.
Okay.
Certificates will be distributed by today evening and tomorrow for every participant.
So by this weekend, yeah.
Yeah.
At most one more working day. So our validity chief guest will be joining anytime. He said he is joining now.
Okay.
Yeah, I think he has joined, ma'am.
Oh.
Welcome.
Akshay. Welcome, sir. Welcome, yes, sir. Sir has joined, huh?
I think so, ma'am.
Okay.
Good evening, sir. Professor Bhaskar, sir.
Good evening, good evening, good evening.
Yeah, welcome, sir.
Sir, welcome.
வணக்கம் வணக்கம் வணக்கம்
வணக்கம் வணக்கம் வணக்கம் இப்படி காமிங்க அப்பதான் எங்களுக்கு தெரியும். Thank you so much.
இல்லைன்னா உங்களுக்கு பார்க்க முடியாது.
ஆமா.
ஆமா.
Shall we start, Akshaya?
Yes, ma'am. Yes, ma'am.
You are convenient.
Yes, sir.
Yes, sir.
Yes, sir. So let us start our function with the Tamil Valtu. Good evening. A warm welcome to all in this auspicious evening. Let us start this valedictory function with the word of Thirukkural. Urayar mun illar pol yegakatrin katrar kadayare kalladavar, which mean with soul submiss they stand as a pupils friend of rich man's face, yet learned man are first, unlearned stand in the lower place. On behalf of the Computer Science Department, University of Madras, it's a moment of great privilege for me to extend a hearty welcome all of you for your MHRD RUSA 2.0 Biomaterials International Congress on Industry Perspectives of Data Analytics. The purpose of education is to replace an empty mind with an open one. I'm happy to invite the pillar of this support, Professor Dr. P.L. Chitra Madam, Principal Investigator, Department of Computer Science, University of Madras, to deliver welcome address.
Most respected, beloved Chief Guest, Professor G. Bhaskaran, Member Syndicate, University of Madras, Professor and Head, Department of Center for Water Resources Management. Most respected Speaker of the Day, Mrs. Revati Subramaniam, Global Managing Director, Data Science, Accenture Operations, San Diego, USA. Dear professors, my dear colleagues, Dr. M. Sornam, Dr. B. Lavanya, Dr. Kadirvalava Kumar sir, and professors from our own university and other institutions across the country. Live voice of the forum, young research scholars and PG students, ladies and gentlemen. Happy evening and warm welcome to one and all present here for the valedictory function of MHRD sponsored RUSA 2.0 International Congress on Industry Perspectives of Data Analytics for 5 days, right from March 7th to 11th, every day between 3 p.m. to 5 p.m. I'm very much delighted to welcome our eminent chief guest of today's pleasant evening, Dr. S. Bhaskaran sir, for this virtual gathering of RUSA 2.0 International Congress on Data Analytics. Hearty welcome you, sir.
Thank you.
I'm very happy to welcome our honorable, ever encouraging, beloved Vice Chancellor, Professor S. Gauri, University of Madras, and thank his support. I'm honored to welcome the Registrar, Overall Coordinator of RUSA 2.0 for his tremendous support. It gives me an immense pleasure to welcome our Biomaterials Team 2 Coordinator, Dr. E. Murugan, Member Syndicate, Professor and Head, Department of Physical Chemistry, for his support. It is indeed a great privilege to welcome our ever motivating, dynamic leader, Dr. S. Balakumar, Professor and Director of Center for Nanoscience and Nanotechnology, who is a source of inspiration behind the scene. It is my inbound duty to welcome our head of the department, Professor Dr. P. Thangaved, and my colleague, Professor Dr. S. Gopinathan, Department of Computer Science, University of Madras. With an immense pleasure, I welcome ever-loving other principal investigator of this project, Professor Dr. M. Swarnam, Dr. B. Lavanya, for their excellent active participation and hosting this event a grand success. Welcome you all. Happy and pleasant to welcome all the professors from our own university and professors from various institutions across the country. It is indeed a great pleasure to welcome all young and energetic research scholars, PG students, those who have participated consistently throughout the 5 days International Congress from the first day to today. I could observe that number of participants present around 86 to 90 and consistently throughout all the past 5 days. Focus area of this International Congress have brought the different flavors of data analytics with business intelligence, machine intelligence, automatic robotic automation, and digital twin in healthcare, and relevance of machine intelligence in today's world by the eminent professional experts from the industries to give the great input to our participants. I hope all the participants have enjoyed and they would have got the joyful learning throughout the past 1 week. Takeaway for the participants are equipping them with data analytics domain knowledge with real-time use cases. I hope this would be useful to them for their career to start their research effectively and flourish in the domain. I wish you everyone a success and welcome you all once again for this forum of this valedictory function. Welcome you one and all. Thank you.
Thank you, madam, for a pleasant welcoming. Education is not preparation for life. Education is life itself. It's my immense pleasure to welcoming our Knowledge Sparkle Associate Professor, Dr. B. Lavanya Madam, Principal Investigator, Department of Computer Science, University of Madras, to give overview about the workshop report.
Good evening to one and all present here. The MHRD RUSA 2.0 sponsored International Congress on Industry's Perspectives of Data Analytics under Biomaterials, Functional Synthetic Material for Biomedical Applications, Theme 2, was held from March 7, 2022 to 11th March 2022 as an activity in the project titled Nanoinformatics on the Role of NanoHap in Cancer Imaging, Orthodontics and Orthopedic, Schema and System Design, organized by principal investigators Professor P.L. Chitra, Professor M. Swarnam, and Associate Professor Dr. B. Lavanya. Department of Computer Science, University of Madras, Chennai, between 3 p.m. to 5 p.m. It is a virtual event conducted on the Zoom platform. The event is live streamed on YouTube on the RUSA 2.0 DCS channel every day and has been recorded for future reference. The participants are from various designations like faculties from different disciplines, research scholars, and PG students pan-India. Totally, 342 participants have registered for the International Congress on Industry Perspectives of Data Analytics. Among these, around 130 active participation is recorded every day. We have participants from various departments like Electronic Communication Engineering, Physics, Zoology, Bioinformatics, Ceramic Engineering, Analytics Department, Theoretical, and Computer Science Department. The participants are from various designations like 50.3% of students, 14.3% research scholars, and 33.7% of faculties. We had active participants from Pan-India. 5 resource persons were invited from various information technology companies, Pan-India and international, specifically USA. Resource persons are from varied capacities in industries like Cognizant Technology Services, MediaNet, Honeywell International Incorporation, Accenture Operations, sharing their knowledge on industry perspectives of data analytics. The first day of the Congress was inaugurated by Professor Dr. A.K. Munirajan, Member Syndicate, Head, Department of Genetics, Director, Dr. A.L.M. PG Institute of Basic Medical Sciences, University of Madras. He sketched on the importance of data analysis in the areas of bioinformatics, genetics, and other domains. The first day speaker, Mr. T. Shivakumar, co-partner, Deus App LLP, former Senior Director Projects, AIMBU, CTS, shared his industrial experience on the topic data analytics with business intelligence. The resource person for day 2, Mr. Naveen Kumar, MediaNet, Senior Software Engineer, Machine Learning, Hyderabad, spoke on the topic data analytics and mission intelligence. The third session was on the topic integrating robotics process automation with data analytics by Mr. B. Saravanan, former Senior Director, Cognizant Technology Services, gave an elaborate oversight on the process automation, robotics design process, and contribution of data analytics into RPA. Day 4 session was handled by Mr. V. Subramanian, Senior Technology Manager, Honeywell International Incorporation, Atlanta, GA, USA. The title of the session is Trends in Advanced Analytics, Digital Twins in Healthcare. He marked out Industry 4.0 revolution, cyber physical systems, and the remarkable revolution happening and going to happen in data analytics using digital twins. On day 5, Mrs. Revati Subramanian, Global Managing Director, Data Science, Accenture Operations, San Diego, USA, elucidated on relevance of mission intelligence in today's world. And now we are in the midst of the valedictory of this program, chaired by Professor Dr. G. Bhaskaran, Member Syndicate Head, Center for Water Resource Management, University of Madras. In this 5 days program, the participants were enriched with knowledge on data analytics need, importance, varied applications, techniques, innovations, product creations, and usage. I hope the participants take home knowledge on many existing techniques, innovative ideas, futuristic vision and exploration for their future research and academic activities. Thank you.
Thank you, ma'am, for sharing a detailed information about this workshop report. Now I call upon our participants to give feedback about this MHRD RUSA 2.0 Biomaterials International Congress on Industry Perspective of Data Analytics.
Yes. Good evening, everyone.
Good evening, sir.
I am Kadirwala Kumar. I am from Virudunagar Hindu Nadar Sandhikumal Nadar College, which is affiliated to Madurai Kamaraj University. Actually, I attended all the sessions with full interest because of the resource persons, the perspectives on data analytics. So far, I have attended only the workshop or seminar by the academicians, but this time, all the 5 days, all the 5 resource persons are from industry. The topic also the industry perspectives on data analytics. The academicians are not talked about industry perspectives on data analytics, but correctly the organizers invited the persons from the leading industry and how the data analytics going on in their companies. But whenever we are talking inside the classroom as a teacher, I couldn't point it out more than 2 or 3 examples for data analytics. Every time we will talk about 1 or 2 examples. Repeatedly, wherever we go, whenever we want to talk about or whenever we hear the question of give the examples on data analytics, we can immediately we can tell some of the 1 or 2 examples. But from these sessions, from these 5 sessions, we could collect more examples in the industries. How they have worked on these areas. How the data on the particular areas are analyzed to solve the problem. Really very, very interesting sessions. The resource persons are very much interested and sincere to give away the knowledge they have occurred in the industry, they have used in the industry. Very good exposure. So really wholeheartedly, I thank the organizers. Also, I feel very happy because the organizers are my friends. So I feel very happy since I am one among these people. I thank God because the organizers are really very good people. They want to give exposure to the academic people, research people. Thanks, ma'am. Thank you, ma'am. Thank you, ma'am. Thank you very much.
Thank you, sir. Thank you so much.
Good afternoon to one and all present here. I'm Gayatri B, pursuing MSc Computer Science at Anadish College. I along with my classmates, take this opportunity to thank all the eminent resource persons for giving us information and widening our knowledge about data analytics and its application. We learned new topics, namely machine intelligence, deep learning, robotics, digital twins, and many more. The presentations were interesting and inspired us with few research topics. We are sure that we will apply these techniques in our projects. I extend my gratitude in this forum to MHRD RUSA 2.0 Biomaterials, organized by the Department of Computer Science, University of Madras, and the International Congress on Industry Perspectives of Data Analysis. Was very useful to us. Thanks to Dr. Chitra ma'am, Dr. Swarnam ma'am, and Dr. Lavanya ma'am for this initiative, and looking forward for many more. Thank you, ma'am. Thank you.
Thank you, Ms. Gayatri. The sessions and the informations reaching the students are the ultimate goal and the objective of this Congress. Happy to hear that.
Thank you.
Good afternoon, ma'am. Good afternoon, I'm Dr. Janaki from Wilmeris College, Department of Computer Science. So I have attended this 5 days program. So every day the resource person was very knowledgeable and offered valuable information such as data analytics with business intelligence and machine intelligence, RPA, advanced analytics such as digital twins in healthcare, and also relevance of machine intelligence in today's world such as fraud detection and management. All sessions was very interactive with real-time use case analysis and more informative. Definitely, it would be useful for to all researchers, and totally we enjoyed and learned a lot through this program. It's a great program, really well organized with plenty of information in each day. Thank you very much. I thank the organizers of this program and Dr. Chitra madam, Dr. Sorana madam, and Dr. Lavanya madam for organizing this wonderful, program for us. Thank you very much, ma'am.
Thank you, Janaki ma'am, for your kind words.
Should I say something, madam?
Yeah, please, sir. If you wish to, please.
Myself, Dr. Pankaj Kumar Singh from ITBHU. Overall, all program was very nice. Especially the first 2 lectures were excellent. Whatever the knowledge we have gained, we should have to try to apply maybe through social networking or in the research purpose. Then the purpose of such type of course will be valuable. Thank you.
Thank you, Dr. Pankaj Kumar. Maybe you have some connection problem. Thank you so much.
Anybody else is interested to say a few words about the feedback? Participants? Okay. Akshaya?
Yes, ma'am. Thank you for all the participants for sharing your kind feedback. Thank you so much. Education breeds confidence, confidence breeds hope, hope breeds peace. I'm glad to welcome Professor Dr. M. Sonam ma'am to introduce our chief guest of this auspicious day, Professor Dr. G. Bhaskaran, Professor and Head Syndicate Member, Department of Center for Water Resource Management.
Thank you, Akshaya. Good evening to one and all present here. Happy evening. It's indeed a great honor for me and privilege to introduce today's speaker, that is valedictory address speaker, Professor Dr. G. Bhaskaran, Professor and Head in charge for Center for Water Resource Management, as well as Member Syndicate. First of all, I would like to thank Professor for readily accepting our request to be a part of this function. Thank you, sir. To introduce him, the list is very vast. Anyway, I will try to concise and give to the audience. He has got many membership of professional bodies like Indian Geographical Society, Indian Society for Remote Sensing, then Indian Institute of Geographers, Pune, India, then the Society of Earth Scientists, Lucknow, India. Like that, he is a membership, lifetime membership in more than 15. And he has got many awards, national and international. Some of the few are, he has been awarded with Commonwealth Fellowship for attending SDP workshop at Staffordshire and Northampton Universities, UK during the year 2008 as well as 2009. And he has got a Best Paper Award, INCA 2012, International Conference at Dehradun. And he has got Media Guild Award of Excellence in Education and Science in 2013, Chennai Metro, Chennai. Then Lifetime Achievement Award during 2014 by Nani Biotech, Chennai. And then Asiriyar Chemmal Award 2017 by Tamil Nadu Institute of Research and Development, Chennai. And before joining University of Madras, he has started his career in Institute of Remote Sensing at Anna University. And during the year 2007, he has joined at our reputable historical University of Madras. So we are very fortunate that we have got such personality to add on a feather on the cap. Other academic activities he has got, he is the coordinator of NSS, then Red Ribbon Club, Youth Red Cross, Cultural for University of Madras, as well as MSc Geography program through IDE, University of Madras, as well as MSc International Environmental Management online course jointly awarded by University of Northampton, UK. And he's developed many modules. And he is expert in many government related programs like Tamil Nadu Public Service Commission, Teachers Recruitment Board, Tamil Nadu Uniformed Service Recruitment Board, then UGC NET SLET, as well as many other universities across the country. And he has got many research publications. In the national, he has got around 50, and in SciIndex, he has got around 10 international publications. And he has got ongoing project funded by RUSA 2.0 during the year 2021-23 with the title Water Resource Management Geospatial Tank Information System for Sustainable Water and Environmental Planning. And he has completed more than 5 projects, and he has conducted many workshops and conferences, seminars, and he has participated in many training programs. And based on the training, he is implementing that in our university as well. So his list is going on and on and on. So I don't want to be in the middle of the speaker. So with that, I would like to stop the introduction about the speaker and let the speaker speak for the purpose. Thank you so much. Now the floor is open to Professor Bhaskar. Thank you, sir.
Thank you very much, madam, for your brief introduction. I'm so happy to be here with you people through that MHRD RUSA 2.0 International Congress on Industry Perspective of Data Analytics. And I'm so much thankful to the organizers, Dr. Chitra Madam, Dr. Chornam, and Dr. Lavanya. I can then the RUSA program coordinator and the participants, nearly 80 participants are there in the meet. So good morning, good evening to all. And this is the privilege to thank all my faculty members and the university authorities to provide a chance in the valedictory function. Yes, this is the topic chosen by the organizer is the right topic and the right time because every movement on the surface is below the surface also monitored by so many devices, electrical and electronic devices. Those devices are providing data sets to us, whether it is organized or unorganized. Data sets are provided every minute, every microsecond. But those data sets are, whether we are using or not, we don't know. The data sets are in the form of either raster file structure or maybe a vector file structure. Those data sets are reliable data sets so that somebody is restricted to use the data set because they may be caught. One day I told my family that I am going to bring something for you, especially this is a special day. Then I went out and my daughter phoned to me, Papa, where are you? So I told her that I am in the market purchasing some wonderful things to you. Then she said that by making a phone call, she said that, no, you are sitting somewhere else. This is the location. This is the latitude and longitude. Sitting comfortably with a group of people, discussing something. You are not in the market. You are not in the mall. Why you are telling lies likewise? So nobody can hide themselves because of this geospatial technology and the data management and data analytics. Though the data is from the electronic and electrical devices, nobody can malpractice. And the repeated data set and information can be put it in the common data pool called your data warehouse or data lakes. So those data sets are sometimes analyzed by the service provider and that can be provided to the end users. Now we are in the digital era using this technology, getting the real-time information for planning ourselves properly. That is a very, very important thing. Data analytics nowadays used by different personalities, different applications for getting the real output for planning well for their livelihood. That is a very, very important thing. Not only the industry, the farmer, the some vendors, business people, and that civilians also using this technology and arriving the data every second, and they are constructing the database and analyzing the database for their own planning activities. Say about the data provided by the electronic devices are very fast, and the data is storing the data is nowadays very toughest job, because the data flow from the different devices. Say about our daily activity. My activity is recorded by our own gadgets, through the satellites, through some other devices. Those devices are collecting the information about my movement. It is continuously tracking my own movement, and that will be recorded in the pool, and also it will be delivering the information to the users where that information to be shared. So that a clear-cut idea to be needed, whether I am going the right way or not, that is to be guided by somebody else, whether my movement is perfect or not, whether my waypoints are correct or not, that is to be guided by somebody else. So that this continuous data sets through some other devices are very much needed nowadays. Even though the data sets are put it in the pool, the data to be analyzed properly, then only the decision will be made by somebody else to guide us, or my own. So that the collection of information through the digital mode, remotely or my own, based on the data, then I have to take a decision. Say about the farmer. Nowadays, in the market, there are some fluctuations, price fluctuation. Say example, tomatoes or maybe the onion. One particular day, the onion price will be 5 rupees per kilogram. But in the other side, in the next month, there may be 120 rupees per kg or 200 rupees per kg, because of the price, the commodity in the market, the price fluctuation taking places. Then perishable good like tomato, it is also price fluctuation drastically. One time that one per kilogram, one rupee, maybe another side, it will be 200 rupees per kg, because the farmers are not following the scientific way of cultivation system, traditional cultivation system. So that one particular period, the commodities are more in the market, another side, there is no supply of product in the market itself. So there is a price fluctuation. So that the farmers are sometimes happy, sometimes they will go for the negative side. Now we are introducing the precision cultivation system through the electric and electronic devices. Precision cultivation system working with the principles of different sensors mounted in the rack, and that will be above the particular field. Every sensor will be recording the data, and every second, every microsecond, every sensor, say about your moisture sensor, will be recording the moisture details. Crop growth, phenological stages will be recorded by our altimeters, and above that surface, that cropland, the atmospheric impurities also being recorded by the another sensor. Likewise, 18 sensors are involved. It will be collecting the information and put it in the common pool as a data, and that will be processed immediately. Then it will be go for the decision support system in the server. The server will be acting differently. How means, if the moisture is less observed by the sensor, then immediately it will be giving a command to the pump motor can switch on. Then the water will be irrigated in the field. When the sensor is satisfied, then the motor will be switched off by the decision support system with the machine learning. So one side, the data is providing the real-time information and build a common database from the common database, I can go for arriving some decisions based on some algorithms. Through that, I can minimize the water for irrigation. And also I am maximizing the particular agriculture system itself. And I will be identifying the growth of the plant in every stage, every phenological stage. Then I can go for the prediction using the predictive analytics based on the growth of the crop, and I can monitor what is the growth of the crop and how, when it will be go for the maturity, when I can go for the harvesting the plant likewise. So this is the month I am going to harvest my own crop, means that time the commodity will be more in the market, so that the price will be sliced. So if so, when I am using the precision cultivation system, using the data and data analytics, then I can predict and I can standardize the price using the other way, the marketing system itself. I can regulate the marketing system itself through the online analytical process, OLAP, online analytical process. So here I have my own online and offline data analytics to take a decision for agriculture practices. If so, the market price will be standardized and the farmer will also be happy, and the customer and the consumer will be very happy because everything is sustainably used. Everything is systematically studied. Every database is collected every day, every minute. That will be more useful for this end farmer, another end the customer. So that the region is so happy about the data sharing and analytics through the online analytical system or maybe the predictive analytics system itself. So we are using the geographic information system software, and the database is nothing but your remote sensing database. So we have two type of database with us. One is the raster-based, another one is the vector-based datasets. Through different sensors, which is mounted in the spacecraft. One is the visible spectrum. It is visible sensor that will be working with the 0.3 micrometers to 0.7 micrometers. There are different wavelengths. The data will be, the object will be same, but the object will be recorded by different sensors in different wavelength differently. So that the behavioral characteristics of the individual object can be recorded, and that will be sent to the ground receiving stations. Those data will be arranged in the particular information system, organized way, and that will be ready for data analytics. Not only the different wavelength, the LiDARs, radar pulses, every second the radar pulses will be received and sent it to the ground. Then that the radar data sets have been used by us for finding out the elevation, other things on the surface. To study the surface elevations, surface temperature, sea surface temperature, everything in the image format. Those images are processed with the supervised classification to take a decision immediately through online analytical process. When the wind will blow towards the land, when the wind will blow towards the sea, likewise the sea breeze, land breeze also can be calculated like this through the scatterometer data set itself. Then there is sea bathymetry also studied by us through the sonars. There is another imaging system to study about the depth of the sea like this. And based on the depth of the sea, based on the sea surface temperature, land surface temperature, the climate also studied by us every minute. There are some meteorological satellite like Kalpana. It is also providing some data sets globally. It will be revisiting the earth surfaces with 11 hours 55 minutes. Every bit of the land is every pixel of that atmosphere will be studied by the satellites. Those satellites are providing the data continuously to us. When we processed, then only we can able to go for tracking the cyclones, movement of the cyclones, when the cyclone going to be cross the particular shore, likewise. So that nowadays, earlier there is a problem with the data, collection of data from the field, collection of the data from the market, collection of the data from the surface. Likewise, there is a problem because the collection is having more, need more manpower and also time. Expense also more. Nowadays, there is no such human is involved in the collection process. Everything is the electrical and electronic devices. Those devices are providing the data in different format. Those different format to be put it in the proper way, then only it will be more useful for various applications. Day-to-day planning also can be when the rain going to become. What is the intensity of the rain? What are the areas affected by the rain in various intensity also can be calculated in the developed countries, not in India, because the radars, the data supply is very, very limited, restricted. But whereas in the foreign countries, they have 5 kilometers, one radar, 5 kilometers, one automated weather station. Likewise, the supply of data is higher the order, then only they can go for the predictive models and they will be giving that warning to us. But here in India, it is not maybe 100 kilometers, one automated weather station or maybe that radars. So that our predictions are perfect, but natural process will get changed every minute. So that we have to increase the devices to collect the repetitive real-time information for the data analytics. Then only we can go for the modeling, predictive analytics to safeguarding our life, to safeguarding our life and effective usages of the resources for betterment of our own life. So I believe that this seminar, this congress will be enlightening so much to you and the field of data analytics. And this particular exercise is very much needed nowadays in India, like a growing country, India, it is needed to take a decision and for the effective planning and implementation itself. So that I thank the organizers to choose a very appropriate topic to the trainers. That is, I cannot say this as a congress, it's a train the trainer workshop, I think so. So nowadays, digital things are coming up more. And now we are working with the migratory birds. How the migratory birds are moving? What is the rate of movement? What is the direction of movement? Likewise, we are studying, and that elephant also tracked by us to minimize the human-elephant conflict. These researchers are needed more amount of data, error-free data from the devices. So in future, everybody will have the chipset and everybody will be tracked every minute. Then the data will be higher, and to take a decision whether in the right way or wrong way through the data analytics. So this is the right time to discuss, right time to learn from this congress about the data analytics for different image processing technique, especially in the biomedical applications. I thank the organizers to giving me an opportunity to discuss with you and share my knowledge, share my experience to you people as a valedictory address. Thank you very much for choosing the Madras University for enlightening your field of research in data analytics through the congress. Thank you all the participants for the patient listening. Thank you very much.
Thank you so much, sir.
Thank you, Dr. G. Bhaskaran, sir, for your pleasant valedictory address. Thank you so much for joining with us. To perform vote of thanks, I call Professor Dr. M. Sornam Madam, Principal Investigator, Department of Computer Science, University of Madras.
Thank you, Akshaya.
Yes, ma'am.
அனைவருக்கும் இனிய மாலை வணக்கங்கள். A warm good evening to one and all present here. It's indeed a great pleasure for me to to be a part of this Congress to propose the vote of thanks. So before starting this vote of thanks session, I would like to say a couplet from our great grandfather, Thiruvalluvar. One is on the topic education and another one is on gratitude. உவப்ப தலை கூடி உள்ள பிரிதல் அனைத்தே புலவர் தொழில். பலரும் மகிழுமாறு அவர்களுடன் கூடி பழகி பின்னர் இவரை இனி எப்போது காண்போமோ என்று அவர்கள் எண்ணி ஏங்குமாறு அவர்களை விட்டு பிரிதலே கற்றறிந்த புலவர் தொழிலாகும். So the great educationist always does the thing that they will make the feeling for the audience that why we need to depart from this such a nice program. So hoping that the audience of this International Congress have the same feeling as I am also having, I just wanted to say this on education. Next, upon gratitude. என்னன்றி கொன்றார்க்கும் உய்வுண்டாம் உய்வில்லை செய்நன்றி கொன்ற மகர்க்கு. எந்த அறத்தை அழித்தவர்க்கும் தப்பி பிழைக்க வழி உண்டு. ஆனால் ஒருவர் செய்த நன்றியை மறந்தவர்க்கு உயர்வே கிடையாது, அவருக்கு மன்னிப்பே கிடையாது. So whoever is forgetting the gratitude, that is to express the gratitude, they cannot be forgiven even by God. So with these two couplets, I would like to propose the vote of thanks. First and foremost, I would like to bow before Almighty for giving us enough strength and health to conduct such wonderful International Congress without any hurdle. Let me express the team's gratitude to our Honorable Vice Chancellor, Professor Dr. S. Gauri, for his ever motivating support. I would like to say our sincere thanks on behalf of our team PIs to Dr. N. Madhivanan, Register in Charge, University of Madras, for his untiring support. Our sincere thanks to RUSA 2.0 Theme 2 Coordinator, Dr. E. Murugan, Member Syndicate, Head Department of Analytical Chemistry. Our heartfelt gratitude to our Captain of the ship, Professor S. Balakumar, Group Leader, who drives us in correct direction by motivating us and literally holding our hands with our little fingers like a father who takes care of his child. Really, we are fortunate and blessed to have such wonderful human being with us. Thank you, sir. I express my sincere thanks to our department HOD, Professor Dr. P. Thangavel, sir, Professor S. Gopinathan, sir, then Technical Officer Mr. M. Gopal, and all other research and PG students of our department. Our special thanks to all our research associates, Mrs. Bhavani, Ms. Jenny, Ms. Sasipriya, as well as Ms. Vagishwari, for their ever-loving hard work and sleepless nights in bringing this show a grand success. Thank you all. I would like to thank all delegates of this Congress Mr. Sivakumar, Mr. Naveen Kumar, Mr. Saravanan, Mr. Subramaniam from US, Mrs. Revati Subramaniam from US, for giving and sharing their knowledge to all our young minds in a very inspirational way. Last but not the least, I would like to thank wholeheartedly all our PIs, Professor P.L. Chitra ma'am, Dr. B. Lavanya, for their dedicated time allocation for running this show in an excellent way. Their planning in a meticulous way to be appreciated. Thank you all the PIs. And a special thanks to our senior, Professor Kadir Valavakumar, who has joined for this meeting all the 5 days and giving us a great support, and really that boosts us to conduct like this type of events in future many. Thank you, sir.
Thank you, ma'am.
So I would like to thank all the participants, all the delegates of this event, one and all present here. Thank you, thank you, thank you.
So that brings us to the end of this.
Certificates will be given within 2 days.
Yeah.
For all the participants. Certificate will be ready, getting
Yeah.
ready to dispatch within 2 days.
Okay.
For all the
Okay,
participants.
thank you, thank you.
Thank you.
Thank you so much for all the participants.
Thank you all participants.
Thank you
And
all.
Special thanks to our
Thank you.
Professor Kadir Kumar sir.
Thank you, thank you.
Yeah. He made the show so lively.
Yeah.
Yes.
Thank you
Yes.
so much.
Thank you.
Thank you very much for our eminent resource person, Dr. G. Bhaskaran, for having spent his valuable time with us to give another data analytics resource person.
Yes,
He has
yes,
given a lot of
yes.
input for the entire participants.
Yeah,
As another
yes.
resource person, thank you so much for your great input, sir.
Yeah. Thank
And
you so
for
much,
having
sir.
spent your valuable time with us. Thank you so much.
Thank you. Thank you.
Thank you all. Thank you all.
Thank you all. Thank you all, dearies. Thank you.
See you in the next moment.
Yes.
Next
Yes.
interesting
Next
event.
meeting.
Yeah, this is our next meeting. We have a national webinar on data analytics sponsored by UGC HRDC University of Madras. It is going to be held on 23rd March, 2 to 5 p.m. We are going to have two sessions. One on machine learning and data analytics, and the other one applications of data analytics in various domains.
Yeah.
So
we have another program also, national webinar on machine intelligence.
Machine intelligence.
Yeah.
It is to be shortlisted very soon, maybe on Saturday. Yes. I wish all the participants to join. You will get a great input with hands-on.
Very good, very good, very good, very good, very good.
Yeah. Next will be on followed by Lavanya and Chitra ma'am. Another one on AI. That will be on 25th March. That is national webinar supported by UGC MHRD. Yeah.
Good, good, good.
Thank you, thank you.
So all the participants do support us for all these three programs also. We are going to have data analytics and then
machine intelligence
and
artificial intelligence. Yes.
Okay.
Thank you. Thank you.